if you have spent any time in computer science, you would know GDB, right? So it's a GNU debugger and it's a powerful and everybody knows it. But here's a secret. Sometimes you don't need a cannon to kill a fly. Sometimes you just need a stone, okay? Just a small things. So look, I just compiled a program and I'm going to show you how you can actually use it. Look. So I got a program here. So it's called as gatekeeper and it hangs, right? It freezes. And if I use a full-blown debugger like GDB, I have to step through thousands of lines of code and it's overkill. But today, and I'm going to show you why strace is most underrated tool for you by using this to crack this binary in I won't say in seconds, okay? But I'm going to show you an easy way. So let's check out a documentation right now. Okay, let's look at this documentation. So it defines strace as a debugging and instructional user space utility for Linux, right? But I think that's way too bit of technical. So isn't it? So if I have to simplify it, strace is a wiretap for software. So to understand why this is so powerful, you have to realize that your program doesn't actually open a file or read a network socket on its own. So it's not allowed to touch the hardware directly, right? So instead, it has to ask the Linux kernel, the manager of your computer, to do it for it. So these requests are called system calls. So think of a kernel as a gatekeeper for the hardware. So the program sends a formal request. The system calls saying like, please open this for me. Please open this file for me. The system will say yes, or it might say no. So what does strace does it? Okay, what does it brings to table? So it monitors every single of those requests. And it's lightweight. It doesn't pause the program's execution, and it tells you exactly what binary is asking for. So and more importantly, what it's complaining about. So when program freeze, it almost always because of it made a system call and the kernel might have not answered it yet. Okay, now let's go to the practical part. Okay, so okay, check this out. So I'm going to use strace right now. So I do have an output over here. So it's tell strace to track any child process that program might launch. So which is common in complex software. So the gatekeeper is our target, right? And whatever is just a dummy input and trigger logic. Look, I know it looks scary, but most of them are just noise. Okay, so I can give you a tip. If you don't know what it means, is that like always check the output at the end, okay? Because if the program is hanging, it often keeps the interesting data at the end part. So this is, here you go. So this is what we're actually looking at. So if you don't know what it actually means in Linux, it means a fast user space mutex. So it's a mechanism that a kernel uses when a program wants to wait for a lock. The binary is effectively saying, kernel, I'm waiting for a signal, but the signal never comes. So the program isn't broken, it's simply stuck at the closed gate. Now we know what we're looking at for, right? So what I'm going to do is I'm going to use object dump d and gatekeeper, and I'm going to okay, let me check this out. So I think it was called as semwait and plst. Okay, look, I just got it. So I'm going to use object dump right now. So right now we are searching specifically for a semwait. So this is a function that creates that lock. Okay, it just creates a lock we found in strace. I'm using C5 because you need to see the instruction that comes before and after it to understand how the program arrived here. Okay, right now we are searching specifically for a semwait. So this is a function that creates that lock we found in strace. So I'm using C5 because you need to see the instruction that comes before and after it. So you to understand how the program arrived here. Okay, check this part. Okay, so 1267 is the call instruction that SemWait has. So this is a digital deadbolt. Okay, the exact moment the program decides to stop and wait for the permission, every time the program runs, it hits this line and effectively pauses its own heart. If you're using GDB, you will have to restart the program, set breaks and breakpoints, and we have to watch variables. I think that's way too much of attention. But what I can do is I'm going to use xedit gatekeeper. Look, I know it's look very too much of overwhelming for you, but don't worry. I'm going to use Control G for a search. I'm going to use 1267, the position of the function, okay, of a SemWait. Okay, I'm here, I'm right. So what I'm going to do is I'm going to replace this with 90, 90, 90, and 90. So if you don't know why I replaced it with 90, because we are going to perform a no operation in the computer architecture x86. In x86, a 0x90 is a hex code for doing nothing. So by typing 95 times, we override that our call command with 5 do nothing command. So if the CPU reads the line and says do nothing, okay, and move on the next line. So we effectively deleted the log by making it ignore itself. Okay, now I'm going to press Control X, then Y, and it's saved. By searching for the main symbol, we find the entry point. Our blueprint tells us the main start at the look, I need to find something over here. Okay, check this out. So 11E9. Okay, this is a part, actually this is a home base, so everything else happens inside this block. So I need to find the perfect one. Okay, check this out. This is the one. So you can, these three, okay, these three line is actually what it matters right now. So what it does is this is a calls for the string compare. It's a function, okay, it's a function, and it compares your input string with the hard coded secret string inside the program. So the result will be when the function finish, it puts a return value into the EAX register. If the strings are identical, the EAX becomes 0. But if they are different, the EAX become a non-zero, like 1 or -1. It could be anything. It's just an example I'm giving it out. Essentially, the program is now remembering whether the result was a match or a mismatch. If you see the next line, the G and E, so it actually stands for jump if not equal. So it asks the GPU, is the 0 flag not set? If the 0 flag is not set, meaning the strings were not equal. If it executes the jump, it sends the program execution pointer to address 129E and the destination address 129E, where the access denied error message lives in. If you didn't match the password, this jump triggers, okay, and if not, you will just get rejected. So what I'm going to do is I'm just gonna keep okay, so what I did right now is just keeping a copy, like a backup file, so that if I mess up, I can go just to the previous stage, because this is a part actually where we're going to do the real deal. Look, now we're going to step more deep into this function, okay? So when I put enter, it actually see. So this is the part. So this was the part, right, where we were discussing about. So right now I'm going to use hex editor again, and I need to find the value 128B. Okay, 75 and 11. Okay, this is what we're actually trying to find. So I'm going to patch it into 90, 90. That's it. And Control X. Yes. Now that's it. Now I just need to check it, right? If the object term T gatekeeper I just need one line, that's it. 128p 128p Yes, that's it. Look, it just changed into 1990. That's it. Now what I'm going to do is gatekeeper. I'm just going to use the same password I execute. See, access granted, and the flag is Gen2 binary master. I know you guys might ask me like, why not just use GDB? Why do you need to do all these extra stages, like all these steps? But here's the reality. Look, you are looking at the C or Python, right? If you're looking at a straight binary, that compiler has wiped away all the variables names and comments. So if you're studying at the machine draw autobiography, the exact instruction that the CPU execute frozen in time. So see, look, GDB is powerful, but it's a manual trap for this. Okay, trying to find a logic bug by stepping into or through the instruction in GDB is like finding a needle in the desert, man. Like, I don't know. I don't think this is a much easier way and this is a more efficient way. That's it. Look, GDB is great. I know it is, but sometimes it's not for everything. Sometimes you just have to take a simple way. So this is one of the simple way that you can actually try.